It is normally very difficult and costly to produce parts with exact dimensions. Therefore, some variations in the required dimensions may be allowed. This variation in dimensions are called tolerance. For example, if I want to produce a shaft of 40 mm diameter, then I can give a tolerance of 0.05 mm plus minus. That means I can produce a shaft which can have diameter 40.05 or can have diameter 39.95. In between these two diameters, any diameter is acceptable. Now in this, a shaft with maximum diameter, this is shaft with maximum diameter 40.05, or a shaft may have minimum diameter of 39.95. This maximum diameter shaft is called maximum metal condition, and this shaft with least diameter is called LML or least metal condition. So this is MML, maximum metal condition, and this is minimum or least metal condition. Now maximum metal is because this diameter is more, therefore more material is there. This diameter is less in this shaft, therefore less material is there. But in case when a hole is made on this plate, in that case maximum and minimum metal conditions are different. Here you can see that in this plate 40 mm diameter hole I want to create. So instead of 40 mm diameter, I can produce 40.05 and 39.95. That means in between these two dimensions, any plate having hole in between 39.95 mm to 40.05 mm are acceptable. Now this is the condition when the hole diameter is 39.95. Now you can see that in this particular condition, the hole dimension, this hole diameter is less, and therefore maximum material will be here. Therefore this condition is maximum metal condition. And this, in this case, when diameter of hole is 40.05, so material left is less as compared to this condition. So this is your lowest metal condition. So LML, lowest least metal limit, and maximum metal limit. To check whether a part is acceptable or not, we can use any measuring instrument to get exact dimension of the part. If you are producing only one or two pieces, then it is good to measure and get exact dimension. But in case of mass productions, we avoid to measure exact dimension, which is time consuming and costly. Instead, we use limit gauges. So one such limit gauge is ring gauge, which looks like this. This is a ring gauge, and it is used to check whether a particular shaft is acceptable or not. Now ring gauges are used in set. So there will be two ring gauges, one for go gauge, one is called go gauge and one is called not go gauge. So here is go gauge and this is not go gauge. So this is the ring gauge, this is one ring gauge and this is another ring gauge, and I want to measure this shaft diameter, the same dimension I have taken, 40 plus minus 0.05. So here I have prepared one go gauge. Its dimension, this diameter is 40.05 mm, and this not go gauge I have made, its dimension is taken as 39.95. Always remember that go gauge corresponds to maximum metal limit, and no gauge always correspond to least metal limits. So because in this particular case this shaft is maximum when the metal condition, maximum metal condition for this shaft is when its diameter is 40.05, and minimum metal condition for this shaft is when its diameter is 39.95. Now what you have to do is you have to keep this shaft here. Now we will try this ring gauge to put inside this shaft. Now you can take any dimension of this shaft. Now I have trying to put this. Oh, so it is going inside. So in case of go gauge, this go gauge should be completely go inside the shaft. If it is going inside the shaft, then okay, first step is over. In second step, we try to put this no go gauge to get inside of this shaft. So I'm trying to get inside. It is not going inside. So this shaft is acceptable. A shaft is made acceptable only when go gauge go inside and no go gauge won't be able to go inside the shaft. In this condition, this shaft is acceptable. Now you can see that if a shaft is shaft dimension is suppose 40.01. So if 40.01, so this diameter of this hole is 40.05, so it will go inside, and diameter of this hole is 39.95, so it won't go inside it because this dimension is 40.05. So in between 39.95 to 40.05, any shaft you take, these two will this will go inside and this will not be able to go inside. That means this is not go gauge and go gauge. When both are satisfied, both these two conditions are satisfied, then this shaft is acceptable, otherwise this shaft is rejected. Now there is another gauge which is called plug gauge. It looks like this. Now it has two ends. One end is for go gauge and another end is for not go gauge. As I explained before, go gauge corresponds to MML, maximum material limit, and not go gauge corresponds to LML, that is least metal limit. Now again I have taken an example of a workpiece, a piece having hole diameter of 39.98. Now I require this same dimension, 40 plus minus 0.05. So I have made one plate with hole 39.98. Now here this go gauge dimension should be 39.95 because it corresponds to maximum metal limit. Now maximum metal will be in this plate only when this diameter is lesser, that is 39.95. So if this hole is lesser dimension, then you will get maximum metal limit. So now try to put inside. So if it is going inside, it is going inside freely. Therefore, this is first step is completed. Now in second step, the same plate is kept here, and again now I turn this, and this part I try to put this part, this not go part, which is of dimension 40.05. It should not go. So if it is not going, okay, it is not going inside this hole, and therefore this plate is acceptable. If suppose this hole is more than 40.05, then it will also go inside, so we will reject. Or suppose if this hole size is less than 40 minus 0.05, that is 39.95, then this go gauge will not go inside. In that case, that means both go and not go gauge will not go inside. In that case, we will reject that plate. This is how limit gauges work. Thank you for watching this video.